So now I understand why Matt Wolf every week is like, what a big week in AI news, because when you're actually following it, it's so much. I watched a 2-hour Nvidia conference and then had to do like another 45 minutes of Googling to understand what I saw. Then it took me 2 hours to listen to Sam Altman on Lex Fridman's podcast, and it took me no time afterwards to realize that he's Lex Luthor. And that was all before starting to summarize the research papers, checking out the new Sora images, writing a mission statement for my YouTube channel to try to get focused. So Nvidia's big announcement is that new chip is bringing us 4 times faster to the singularity. And we found out that a whole bunch of AI agents are debugging, writing code, and internally designing chips. And while that was taking place, big tech reinvented the brick.
There is no nuclear facility.
Sam Altman told Lex Fridman that he does not have a secret nuclear facility.
That's what a person with a nuclear facility always says.
Stability.AI released a new image to Orbital video model. New report shows that in China, they're using 12 times the amount of robots to build American goods as we thought they were using. And some random guy soldered a jet engine to a drone, and it can now go 250 miles an hour. Now, before I get into the news, we are 72% of the way to AGI. So for us humans, let's enjoy our intelligence dominance for as long as we can, because I know that's coming to an end. So why don't we use it to look at some new images that came out of Sora? I mean, look, who hasn't wanted to see a potato dressed as a king spinning around its other little potato minion citizens? Oh, all right, but let's get into what you really want to know about, the Nvidia conference.
And so, ladies and gentlemen, I would like to introduce you to a very, very big GPU.
But how big is it? Is it big enough to calculate the exact moment that I stop caring?
208 billion transistors.
Whoa, 208 billion transistors?
These two sides of the Blackwell chip have no clue which side they're on.
We no longer have chips complaining they're on the left side. God only knows how much drama that has caused over at Azure. I'm just giving them a hard time. This honestly is an incredible breakthrough, but when I really got interested in this presentation, it was towards the second half when I started to realize how they actually built this. It really took AI agents, chip designing AI agents, to teach them a new way to think about chip design to get there. And that, I think, should be the headline story from this presentation.
And so we have a great idea. We're going to invent a new way for you to receive and operate software.
A new way to receive and operate software? All right, I'm all ears. Let's see what you got.
This software comes basically in a digital box. We call it a container.
A container. Got it.
What's inside it is incredible. You have all these pre-trained, state-of-the-art open source models. They could be open source. They could be from one of our partners. It could be created by us, like Nvidia Moment. It is packaged up with all of its dependencies. So CUDA, the right version. cuDNN, the right version. TensorRT, LLM, distributing across the multiple GPUs. Triton Inference Server, all completely packaged together. It's optimized depending on whether you have a single GPU, multi-GPU, or multi-node of GPUs. It's optimized for that. And it's connected up with APIs that are simple to use.
So this is where we start getting into the world of science fiction, and I'm so impressed with what they've done. This is clearly the way the future is going to go. So you hear him talking a little bit about this is how software development goes. You've heard me talk about how you'll have teams of agents that call on one another for different reasons. Now, to package an entire LLM with those CUDA dependencies, all that technical stuff, and then make it its own little piece, like an API that can fit between 2 other pieces of hardware, changes the game. In the future, you could probably get some kind of an Nvidia GPU. You plug it into any computer in the world, some like old 2000s PC in a PCI slot, or some cutting edge rack server at Azure. And instead of going and looking for drivers or reaching out to the cloud and actually reading code that says, hey, I need this or I need that, or repositories that are, perfectly assembled so that it knows how to talk to it, the large language model that sits behind it can write the custom code. If you plug it into an old computer, imagine it says, whoa, this is like an old 2000s computer. This is like a Pentium processor. Hold on, let me like roll back the CUDA version to what will work. Maybe I can like reconfigure the way that we connect so that you can actually use this. So every video game you play, it just knows how to talk to it. Every time it's in a cloud server and it gets a request, it knows how to talk to it. How incredibly convenient, versatile would that be? That GPU would be worth much more than an equivalent GPU from another company because it would be plug and play compatible everywhere. The large language model is literally fixing it all the time. Like a dishwasher that like breaks and then it just recodes itself to fix itself every time because the software doesn't break. It just is a large language model that can go ahead and be updated and fixed. A refrigerator, an actuator, a robot in the future that has that in all the knees and arms and legs and fingers and it's constantly adjusting. Hardware that's connected between an AI as the API is mind-blowing to me.
There's going to be one of these chatbots, and these chatbots is going to just be in a NIM. And you'll assemble a whole bunch of chatbots. And that's the way software is going to be built someday.
But then you think about it a little bit more. Could another NIM, another model that's packaged together with important stuff that it needs to use to talk to two pieces of hardware actually be the conductor, the orchestrator, the planner of many other agents?
How do we build software in the future? It is unlikely that you'll write it from scratch or write a whole bunch of Python code or anything like that. It is very likely that you assemble a team of AIs. There's probably going to be a super AI that you use that takes the mission that you give it and breaks it down into an execution plan. Some of that execution plan could be handed off to another NIM. That NIM would maybe understand SAP. The language of SAP is ABAP. A manipulation on it. Maybe it's an optimization software. It gets combined with everybody else's, and because it's been presented with this is what the right answer should look like, it knows what right answers to produce, and it presents it to you. You learn its meaning, you encode its meaning, so now this becomes an AI database, and that AI database, in the future, once you create it, you can talk to it. And so let me give you an example of what you could do.
Imagine at Nvidia, they have bugs all over the place, right? They're working with all these servers and all these PC companies, and people write like, oh, it crashed, and I was playing this video game, and it doesn't work, and my server's not properly working, blah, blah, blah. All that stuff goes into some giant Jira type system, right? And there's some humans that are trying to figure out what's the most important because, like, you know, one client is worth a lot of money and another one's really not worth our time. Like, what bug do we squish? We only have so many employees. Throw all of that away. Put all of that Jira information. Also, go out on the internet, scrape all of Reddit. Go find out people who are just complaining about NVIDIA in the YouTube comments and all those things. Dump them into a big repository. Train the model on that data. Find the meaning in that sentiment. And then ask it, what bug should I squish right now? And it just pops up to the top. Now, if a human looks at it and says that really isn't a priority because A, B, and C, then you train the model with reinforcement feedback and it goes and it gets better every time. But assuming that it does bring you with superhuman intelligence the next thing that you should squish, it's not even the end of the story. Then they have an AI that can code, solve the problem, right? It fixes the bug, the highest priority bug, squashes the bug. It gives it to a person to just approve, to look at it and say, is this the right solution? Did you really code it right? Of course, if it doesn't, it says this is the way you actually squish this bug. Then the system gets smarter. So they are entering an iterative cycle.
For our software team, you know, they just chat with the bugs database. You know, how many bugs was there last night? Are we making any progress?
But it's not just bug squishing, it's also chip design.
You might not be surprised, we care a lot about building chips. And so we want to build chatbots, AI co-pilots that are co-designers with our engineers. And so this is the way we did it. So we got ourselves a Llama 2. This is a 70B, and it's, you know, packaged up in a NIM. And we asked it, you know, what is a CTL? Well, it turns out CTL is an internal program, and it has an internal proprietary language, but it thought the CTL was a combinatorial timing logic, and so it describes conventional knowledge of CTL, but that's not very useful to us. And so we gave it a whole bunch of new examples. This is no different than onboarding an employee. We say, thanks for that answer. It's completely wrong. And then we present to them, this is what a CTL is. Okay, and so this is what a CTL is at NVIDIA. And the CTL, as you can see, CTL stands for Compute Trace Library, which makes sense. We were tracing compute cycles all the time, and it wrote the program. Isn't that amazing? And so the productivity of our chip designers can go up. This is what you can do with a NIM.
So this chip, this Blackwell chip, wasn't entirely created by human engineers. It was created by a huge repository of internal data and some external data. And they said, what's a better way to design a chip? How do we get past these hurdles that seem like they don't have solutions? And it designed it. And then they looked at it, and it's an iterative process between the engineers that are human and this new digital engineer. So if you think about it, you have this Nemo microservice that's giving access to all of these NIMs. These NIMs are going out there self-organizing. You have this master controller. You've got a system inside of NVIDIA that's already in some cycle. They will be only competing with other people who have a cycle that moves that fast. But this is going to go beyond anybody who has a traditional system of iteration of humans. It already seems superhuman to me.
We need to adapt, and we need to know what's coming. And so we're creating Earth 2, a digital twin of the Earth.
They created another Earth. All these simulations that they're doing with digital twins, when they built a gym to train virtual robot models, in the same way we talked about those Disney robots. Actually, you'll see the Disney robots in the NVIDIA presentation.
Amazing Disney research. Come on, you guys, let's wrap up. Let's go. Where are you going? I sit right here.
Sort of flowy and like move actuators in ways that feel much more human, because in the simulation, you can just do it all day long and there's no restrictions. The motors aren't going to like actually bump into anything. So you just like cycle through millions of iterations, and then you just dump that into the robot that you've perfectly simulated. And you do the same thing with like building factories and building objects like this transformer here, Grimlock. Like you could imagine building the whole thing first, making sure that it transforms. And then it's just crazy. Like these things, they're born in the cloud, they learn in the cloud, and then they're just downloaded into bodies. And all of a sudden, out of nowhere, these robots just seem incredibly talented and skilled. And you wonder how it was programmed. And it wasn't. It learned. You just didn't see it learning. So no wonder Figure AI rushed that OpenAI model out, because like NVIDIA and them were doing it at the same time. Should have known behind the scenes NVIDIA had this whole thing going also. Like robots are coming so much faster than I expected. All right, so now I want to jump over to these brick connecting magnetic robots. I've never thought about this before, but bricks, like the just normal red bricks that you normally would have built a house out of, imagine if each one was a drone, okay? Carbon fiber, right? Big carbon fiber rectangle sitting around the drone. They snap together with a little bit of magnetism. Maybe around the outside, you actually put something solid that you can't see through. Now, all of a sudden, you could program these in swarms to just build a structure out of nowhere. Imagine a few thousand of these things charging up, and then you go, say you lay down on the ground and you're just like, I'm gonna take a nap here, like a sleeping bag or something, and they just build a home around you, like a protection. Maybe that's the future of camp. And this guy in the comment section had a pretty interesting idea too, where they magnetize, snap together. If that could carry a current, you could probably charge one of them and have like all of the bricks in the home charged at the same time, and then they could all fly away or like reassemble when needed. You throw a large language model into that thing or some kind of future version of NIM so the hardware can actually talk to voice in more and more advanced ways, and then you just ask your home to change shape for you. Like imagine a firefighter not needing to actually go up a ladder to get to somebody on like the 20th floor or something of a big building, right? You just send up a bunch of these and it literally makes a flying platform. You like jump into it, crowd surf or something, You land on it, takes you down to the ground safely. If they're, if they're strong enough to hold a human, which eventually they could be. We get better battery technology and all that. But wouldn't that be weird? Or maybe even like stand on him, or they make like a throne and then you just like the throne flies away with you on it. Who knows where that goes? But that's a fascinating idea. So this new model is called Stable Video 3D. Stability.AI, they've been in this game since the beginning of these diffusion models. They have a new model to talk about, and what it does is it takes an individual image, kind of like Nerf, we've talked about this in the past, and tries to imagine what the other side of it is. But because it's been trained on tons of three-dimensional data from one-dimensional photos, it can make those correlations. Look at how accurately it can take a one-dimensional horse like that and show all the sides of it. Spaceman, Lego character, whatever it is, purse. Now, in the past, a lot of the Nerf stuff that I've seen looked a little wonky. Like, I don't know how to describe it. Almost like grainy or sort of like foggy. So I was impressed with the sort of plasticness or the smoothness or the kind of the way the lighting is on these Nerf images. And they've added a couple things to this to make it better. One is called a masked score distillation sampling loss. And then another thing that they've done is to reduce the issues of the baked in lighting. So, when you take a photo of something, there's light from a certain source. Now, when you turn it, it's not going to be that same lighting source. So that's another place where these Nerfs often fail. So they came up with another element to the model called the designed illumination model that is jointly optimized along with the 3D shape and texture. So there's a lot of different things going into the same Nerf technology to make this thing three-dimensional. And to be honest, it's pretty much the best that I've seen. I mean, to me, they look like little figurines or little toys or something that does kind of feel like the lighting is correct as it turns around. So we've got some new commentary from OpenAI's CEO, Sam Altman. He was on the Lex Fridman podcast for round 2 today. So many questions we want to know from you. What happened when you got fired?
2 of the board members called and said, hey, we didn't mean to destabilize things. We don't want to destroy a lot of value here. Can we talk about you coming back?
Oh, heaven forbid we destroy a lot of value. Please come back. Not the most important thing right now, okay? This is AGI that we're about to come across. 73% of the way there. Inquiring minds have to know. What's your thoughts on Elon Musk suing you?
So I think he'd have more empathy for this.
OpenAI and a lot of amazing people here chose to part ways with Elon. So there's a personal
Elon chose to part ways. He thought OpenAI was going to fail. He wanted total control to sort of turn it around. We wanted to keep going in the direction that now has become OpenAI.
Okay, I have never heard Sam Altman actually explain the breakup with Elon before. This is what's come out, and he says it for the first time that I've heard straight from the horse's mouth. Yeah, it was Elon that wanted control, and they were like, that's too much control for one person. You got to go.
He also wanted Tesla to be able to build an AGI effort. At various times, he wanted to make OpenAI into a for-profit company that he could have control of or have it merge with Tesla. We don't want to do that, and he decided to leave, which that's fine.
Partnering with Microsoft because he was trying to get them to partner with Tesla. Like, OpenAI is super valuable, and they need a big company that can build a huge server cluster to train all this stuff on. And he's either got to provide it or he's got to get out of the way. He wants it to be for-profit. Of course, this is how it went down. That's, of course, where the lawsuit is coming from. Jealousy. Maybe an attempt to slow down somebody who seems to have an advantage right now. It's clear as day to me. Remember a couple days ago when the CTO of Sora was asked, where did that training data come from to make it so good? And she was like,
I don't know. Not sure.
Or, okay, yeah, maybe you can tell me, in order to deal with occlusions, what does the world model need to?
Yeah, so what I would say is it's doing something to deal with occlusions really well. What I represent that it has like a great underlying 3D model of the world. It's a little bit more of a stretch. It looks like this approach is going to go surprisingly far. I don't want to speculate too much about what limits it will surmount and which it won't.
and here's the thing. He was surprised at how well it's dealing with occlusions, meaning something that's like in the background, having some sort of physics of the room that it's, creating or generating on the fly. And if this does, like he says, not seem to have a limit, this might just scale up indefinitely. This is pretty much another like transformer language token thing where there might be another big breakthrough here. Another thing that you can really lean into and have the first mover advantage. It's pretty incredible. If OpenAI does this twice, it's just like, man, they are on fire.
When is GPT-5 coming out again? Blink twice if it's this year.
We will release an amazing new model this year.
Boom. There we go. We got it. GPT-5 2024. He didn't do the 2 blinks to throw us off, but he just said it out loud.
I don't know what to expect from GPT-5. You're making me nervous and excited.
You're making me nervous and excited.
A lot more people have died of air pollution than nuclear reactors, for example. But most people worry more about living next to a nuclear reactor than a coal plant.
He's right. I actually think about this all the time. Like, we do, as a society, need to start worrying about stuff that actually kills us. Yeah, 1 point for Sam there.
But something about the way we're wired is that although there's many different kinds of risks we have to confront, the ones that make a good climax scene of a movie carry much more weight with us than the ones that are very bad over a long period of time, but on a slow burn.
Elon just tweeted something like the silliest outcome is the most likely or the most ironic or something. Oh my God. When did Elon get so political? It's like every single one of these. It's just like Biden's border bloodbath. Oh yeah, there it is. The most entertaining outcome, as if we're in a soap opera, is the most likely. I hate that that's true, but I think it is. Like, you know, if I was dressed up like a clown right now and I use squeaky sounds instead of the word this video would get 100 times more views. Finally, the hard-hitting question I've always wondered. Does Sam Altman think we might be living in a simulation created maybe by an artificial intelligence? The answer, please.
Yes, somewhat.
Oh, there it is. I rest my case. We're somewhat there.
There are these like very simple sounding, but very psychedelic insights that exist sometimes.
Wait, quote, psychedelic insights?
So the square root function. Square root of 4, no problem. Square root of 2, okay, now I have to like think about this new kind of number. Then you can ask the question of what is the square root of -1?
We're going to square root of -1. That's right, off the 2-dimensional timeline. Actually, this is pretty interesting to me. If you remember this video, it's called Is the Complex Number Line the Future of AI? I kind of went into some of that.
I don't know if you're like me, but if you are, then you're completely fascinated by the complex number line. And if you stick with me throughout this video, I'm gonna show you how complex numbers might revolutionize the way that artificial intelligence systems are.
Too nerdy. All right, so the Information Technology and Innovation Foundation put out a new study, looked at a lot of the ways that technology in China is growing, found a big discrepancy with how many humans versus robots are working right now making stuff. Look, this country makes a lot of great hardware. The company DJI already freaks me out. They are so good with drones and gimbals. They're hot on our heels when it comes to robots, like fully humanoid robots. China is already the largest industrial robot market in the world. It accounted for 52% of robot installations worldwide 2022. So here we go. Figure 2, industrial robots per 10,000 manufacturing workers in 2022. So you can see Korea is the most robotic, Singapore, Germany, Japan, China, and we get way down here in the middle, United States. I don't know if I feel good or bad about that. Probably would be happier if we had more robots. But actual robot adoption rate as a share of expected robot adoption rate, boom, China takes the lead. We are not moving fast enough, okay? So check this out. That drone DeLorean has a rocket engine put on it. 4 micro turbines. That's crazy. So you lift it up horizontally, just like any other drone, then just like straight rocket engine forward, and then when you want to slow down, straight rocket engine pushing you back. Imagine looking out your window, you see a drone, takes a photo or whatever, turns around, just rockets off. Another thing I didn't know existed. All right, so the first paper we're going to talk about today is this paper called MusicHiFi Fast High Fidelity Stereo Vocoding. Video coding, sound encoding is what it means. So the cool idea here is to take some old recordings that just don't have the highest resolution, make them way better. It's kind of like upscaling, but for audio. And then more than that, it can take some channels that are just mono, meaning there's just like one audio source capturing the room, and split them up into stereo or even 3.5, so you can actually have certain sounds feel like they're coming from the left and the right, create more dynamic sound. It's fascinating that it works. Now, we've seen stuff like this before. They can actually take minus tracks. It can like pull out voices. It can pull out drums, things like that, to varying degrees of quality, I would say. Like, I was listening to it and I was like, no, I can hear other stuff bleeding in still. But it is emphasizing to a point where you're like, okay, we're making steps towards this problem. So this model is using 3 different GANs. These are those generative adversarial models, the neural networks that actually compete with one another to get better and better. And by doing that, they seem to have had some pretty good success. So the 3 GANs were focused on different aspects of making music or sound higher quality. Right now, the stereo from this sounds much better. Now, it might not come through because of the way I'm like recording my screen in mono. It's not using the left and right signal, so might not do it justice, but you can check out this URL, musichifi.github.io/web. Imagine old recordings of like the Beatles and stuff are just going to sound like so crisp and modern when they're upscaled soon. All right, next up, controllable text to 3D generation via surface aligned Gaussian splatting. Tell me you didn't want to find a way to fit the word splatting into a scientific paper. That was probably the goal of this guy, especially Zhi-Kui Li. You know he wanted to get splatting into a title. But what do we really got going on here? So this paper is all about generating 3D images from textual description. So this is like typing something into DALL-E and getting an image, but getting a 3D model. So they've introduced a new framework that seems to be better with geometry and texturing. And so Gaussian blur is something I'm kind of familiar with in Photoshop. So some kind of blur is what I think they're getting at here, which makes sense. It can kind of smooth something out, especially if you have a more like multi-dimensional blur. And the way they're doing it is with a new technique that they're calling sugar, capital SGR, sugar. And that describes this kind of special sauce they've come up with, which is the pipeline for how you make it 3D, where you kind of blur it, where you kind of make it more tight, how you do it the lighting. So you can see with the prompt, a baby dragon digital art masterpiece, its tail cocked to one side. We end up with this conditional image, and the textured model just, you know, pretty cool. We can zoom in on that little guy. All right. Let's see how it does with human faces. One girl, beautiful, photorealistic portrait upper body, middle hair, 20 years old, off-shoulder blouse, extremely detailed. All right, so looking at the sugar version versus the 3D mesh. Let's go all the way around her. So yeah, hair off the shoulder looks right. I mean, I think it looks really cool, although I don't know if that's what people are going for. There's so many weird miscolors in there, but I think they look neat, actually. Oh my gosh, she's hollow. You can just see right into her like that. Oh, Batman. Masterpiece Batman portrait upper body superhero cape mask. Conditional image, textured mask. Yeah, text to 3D is coming soon. Another thing that I didn't mention in the Nvidia presentation, they do have a stream from their supercomputing system right into the Apple Vision Pro. So the Apple Vision Pro is getting some information about the way your head's tilted, where your eyes are, all of that stuff, sending it up to Nvidia, where they can, in theory, start diffusing full 3D environments, sending just the minimum compressed data back to your Vision Pro, and you can just, you know, stream from the cloud these crazy environments. And if it's in the cloud, then it could, you know, be synced to a whole bunch of other people, and somehow it could be environments where you're socializing, or at least you have like kind of a ground truth that you're all based off of, which would be pretty amazing to have Oasis from Ready Player One world, where you're just saying like, generate this, and it shows up. But other people in the room would see that too. So like Harry Potter, you could all be magical, creating things, floating things, controlling things. Like, so for all of you guys supporting me, the super chats, the likes, the subscribes, they have been great. I don't know, the algorithm's not responding instantly, but if we keep this up, maybe we can start getting to that 1,000 view goal per video. Obviously, these videos take me a ton of time to research, to film, to edit, and all of that stuff. So I'd love to have more people view them, but I also am at the whim of the YouTube algorithm. However, I did want to share the stats from my last video. I did make $20. I did get 1 new subscriber. You know who you are, thank you. And look, 515 views, 60 hours of watch time was better than my average, so we are making progress. Let's go see what the gender breakdown is. Oh, 0% female. No worries. No, I mean, it doesn't matter. To each their own. But 4,000 impressions is a bit more than I'm used to. 7.2% click-through rate. Actually, I mean, normally that's a pretty good click-through rate in my opinion, but it has been a bit lower than my last few videos too, but it's okay. And I was excited to see that a few more views are coming from the search term. So Figure AI, Grok, Devin. I've also got some really nice emails from people, including one really big YouTuber. Should I mention his name? Probably not. But there is a big YouTuber that's in my space, really, really nice to me. saw that I was having troubles. I actually reached out to him first, but then he wrote back with a question about what the mission is of my channel and a few other questions. So I thought I would give you the answers to that just because I spent a lot of time thinking about it. So he asked me some important questions about my channel, and I was like, okay, let's think about this. Like, do I have a mission statement? Which I kind of didn't, but when I sat down and thought about it, I figured that the main reason I'm doing it, if there is a mission that I'm following, it's to build a cooperative community to navigate the singularity with. I just see it coming, and I think, God, like, how are we gonna deal with not being the most intelligent species on Earth? We should come together or like try to align it. You know, all this stuff that everybody's talking about. I just see that coming very clearly now. What animates you here? So I tried to think of times on the channel when I've been the most animated, because what YouTube seems to be about is like connecting authentically with people. So less scripting, more just telling you how I truly feel. And when I'm the most, I'm not that emotive just generally, like I'm kind of like neutral just by personality, but when I do get the most worked up, it's usually because of people who are using artificial intelligence for weapons. Oppression, profits, all of man's worst qualities, and that bugs me the most. That's when I get the most like furious, I guess you'd say. Then he asked me, what do I genuinely care about? And I wrote back that I care about how we're going to adapt to the fact that intelligence seems to be something that just can emerge from complex systems. It's not inherently just human. I mean, think about it. The 7 billion people on Earth are going to have to go through this kind of Copernicus moment where we're not the center of the Earth. And guess what? Intelligence, as special as it feels, because we're the only biological life that has anything like this, and we've built this empire. We've controlled the planet with it, top of the food chain, and we're about to give it away to something else. Possibly for most people, because they didn't even know you could give it away, that wasn't just inherently like part of our soul, part of our body. Like, this is something that can be replicated in silicon and other substrates, and we have sort of figured it out, I think, at this point. And there's improvements to be made until it gets away from us, but we're clearly on that path, in my opinion. And then another thing that can get me emotional, but like not with the negative spin because people use it for weapons, but it's just the kind of like awe-inspiring feeling that me and you are both here right now. Don't know why, with millions, billions of years of evolution, 20 million years since our last common ancestor with monkeys, and we are here right now. Out of all the humans, we're the ones right now going through pretty much the singularity. I think we're going to go through the singularity. I think it's writing on the wall in maybe 10, 20 years, but we could both be alive at that point. And that's just crazy that out of technological progress that took, 4.7 billion years from the beginning of life, somewhere down in the ocean, it all came together, and systems and complex fats came together and organelles and conquered the Cambrian explosion, got onto land, developed hearing and sight, and neurons built on each other to have more and more foresight, and went back into the water, and then went into the sky, and then one branch happened to have language evolve along with other highly social attributes, and the environment was right to make us the way we are, and we had other hominids, and we killed them and fought with them probably, and the Neanderthals merged into what we have right now, which is just humans. And with this ability to work together, to actually have memes kind of pass along generation after generation until we can harness all this technology thanks to the good of people that came before us. And we have figured out something really important with the transformer model and with neural networks that is working surprisingly well. And now we're at the very end. Like, I'm not making these wild guesses about like all this crazy stuff. To me, it seems like it's crazy that we got here. Now it seems obvious. So anyway, share this video, maybe like $1 super chat. I think that's a really good signal for the algorithm. Thank you for staying with me. This is probably the longest video I put up for a long time. So yeah, it is what it is though. There's just crazy stuff going on. Lots to talk about. Thanks for being here with me.